Hey guys, Miss Nguyen here with our notes video for translations. Okay, I'm gonna go ahead and get right to it. That's what I meant to say. Okay, so when you hear the word transform or transformations, what do you think of? Okay, when I asked my classes, a lot of them were like Transformers, like the movie, because yeah, you have a car that transforms into a robot, right? So that's definitely a good example that we'll keep coming back to. But the main word when you hear the word transform that you should think of is the word change. When you transform something, you're changing it, like a magician changes a handkerchief into a bird, right? Or like with the Transformers example, when you have a car that transforms into a robot, that's changing its shape, right? So to transform a figure means to change it. Change this color to green means to change it, just like how I just changed the color from purple to green. When we're doing transformations on the coordinate plane, right, we can change the shape's size, location, or direction. Okay, so that's what we're dealing with here, is transforming shapes that are on a coordinate grid. Okay, for every transformation we have two figures that we're dealing with. We have the original figure before we do anything to it, before the transformation. We call that the pre-image. Okay, the word pre means before, or it's not a word, I guess, but it's a prefix. When you have a word, most of the words that start with pre mean before something. Like a prequel is a story that happens before the main story, whereas a sequel happens after, right? But prequel happens before. Or like a pre-test is a test you take before the real test, or like a practice test, right? So pre means before. So the pre-image is the before. And then when we have the new figure after being transformed, that is just called the image. So the pre-image is the before and the image is the after. Okay, we also mark it with this little apostrophe symbol, okay, whenever we have a name. So for example, if the pre-image is called, figure A, then after we transform it, the image will be A with a little apostrophe on it, except we pronounce that apostrophe differently. If our new shape is called B with an apostrophe, we pronounce that as B prime. Okay, just like how Optimus Prime is the name of the robot. So you have a car, and it changes into Optimus Prime, which means I guess the car is just Optimus. It's Optimus, and then it transforms into Optimus Prime. Alright, so hopefully that's how you can remember it. Okay, so before we get into what we're doing today, which is focused on translations, we need to talk about a couple of key words, vocabulary words that we're going to use throughout this unit. Okay, the first one is congruence with a CE at the end. Well, that looks very similar to the word congruent, right? Now, what does it mean when two figures are congruent based on our previous knowledge? Okay, when two figures are congruent, it means that they're the same size and the same shape. Now, I mean, anything can be congruent. Two numbers can be congruent. Two angles can be congruent. But when we're talking about congruence with, transformations, we're talking about the shapes. Are the shapes congruent? Yes or no? Okay, so congruence refers to whether the pre-image and the image of a transformation are congruent or not. Okay, and so congruence is the noun, and congruent is an adjective. So there's two different ways to ask the same question. You could ask, okay, are the pre-image and the image congruent to each other? Or you could ask, okay, when we changed the pre-image into the image, did it preserve congruence? Okay, both of those sentences mean the same thing. It's just a different way of asking. Okay, so congruence with the CE is the noun, whereas congruent is an adjective. Two things are congruent, or two things have congruence with each other. Okay, the next vocabulary word we need is orientation. That's a word that you might already know. Okay, orientation deals with the direction that something is facing. Like, for example, most cars nowadays, if you look on your dashboard or where the clock is, it has a couple of letters like N or SW. Well, those are the directions, and it tells you, okay, your car is heading in this direction. Your vehicle is oriented in this direction. So orientation deals with the direction that something is facing. Okay, so with transformations, we have two different kinds of orientation. The first one is orientation of the figure. That's basically the direction the entire shape is facing. Is it pointing to the left? Is it pointing to the right? You know, the whole figure. Like if I turn, my head is facing this way versus my head is facing this way. Like my whole body, the whole figure is oriented a certain way. Okay, the other type of orientation is orientation of the vertices. Okay, and remember vertices are our corners or our points on shapes. So orientation of the vertices is talking about the order that the corners of the figure are labeled. Like, for example, in this picture down here, is labeled ABC, so that's the orientation of the vertices. And sometimes in certain transformations, when we transform it, it won't be ABC anymore. It'll change to like CBA or something. Okay. Now, translations are kind of a boring transformation for orientation because nothing really changes, but we'll get into transformations later where those things do change. So it's good to get used to the vocabulary now so that you can use it later. Okay, so with that, we are finally ready to talk about translations. So the main point of today. Okay, so translations are one of the 4 different types of transformations. Each of them is a very different kind of change. Well, a translation moves every point of a figure the same distance in the same direction. We also call this type of movement sliding. We slide the figure. Okay, so a translation is just moving a figure. We're not flipping it, turning it, anything. All that happens is it's here, and then it moves over here. Okay, which is why I said that it's kind of boring in terms of orientation and congruence, because none of those change. Okay, if I'm facing this way and I walk a couple steps forward, I'm still facing the same direction. Nothing about me has changed. Okay, so let's look at this picture here. First of all, how do we tell which one of these is the pre-image and which of these is the image? Okay, well, the main thing we're looking for are the little prime markings. Okay, when you see these little prime markings on the letters, that means that that shape is the image. It's the after, because we only add the prime marks to say, oh, this is after we already transformed it. So we add the little prime marks because it's not ABC anymore. Now it's A prime, B prime, C prime. So if this is the image, that means this must be the pre-image. It's really important that you distinguish which one is which because that affects the movement. Since we know that this pre-image is the one in the lower left hand corner, that means that this shape moved up and to the right to get to the image, right? But if we got this mixed up, then we would think, oh, it moved left and down, but it didn't. Okay, so it's very important that you understand which one is the pre-image because that tells you where you start. And that's going to affect like the math that we do here in a little bit. Okay, so this shape, the figure, we would say the figure moved up and to the right. That is at its most basic, right? Here in a little bit we're going to figure out a little bit more of the exact numbers of like how exactly did it move, how much did it move. But for now you can at least tell by looking at this that it went up and to the right, or to the right and up. There's always going to be 2 directions. There might be rare cases where it only moves up or something, but in most cases it's going to move up and down and left and right. Okay. So, well, that's all well and good. I think anybody can tell that it moved up and to the right, but what are we going to do math-wise with this? Okay, this is where this part comes in. We're going to talk about the algebraic rule. Okay, to represent a transformation mathematically, we use an algebraic rule, or we also call it an algebraic representation. Representation. And here it is. The algebraic rule for translations, start out with x, comma y, so that's the original coordinates, changes into x plus or minus a number, comma y plus or minus a number. And this symbol here, means plus or minus. So it could be either. Okay? The xy represents the pre-image coordinates. So those are the coordinates before we change them, do anything to them. And then this second part, the x plus or minus a, y plus or minus b, represents the image coordinates. Okay, now let's think about the x and y axis. I'm going to draw this over here in the corner. Okay, our x-axis is the one that goes from side to side. Our y-axis is the one that goes up and down. So based on that, you can probably guess that changes to the x-coordinate will slide a figure horizontally. It will slide the figure side to side, left to right or right to left, right? Okay, well, when we are on the x-axis here, so let's look at this x-axis right here. Okay, when we are on this x-axis, when you move to the right, the numbers get bigger, right? Like if we were to label this 1, 2, 3, the numbers get bigger as you move to the right. So that means when you add to x, you're moving the figure to the right. Okay, if you have x is 1, and you add 2 to it, to get x is 3, you're adding and it's moving that point further to the right. Okay, now likewise, the x-axis goes the other way, -1, -2, -3. It gets smaller. The numbers get smaller as you go to the left. So if you have a point at x equals -1, and you move it over to x equals -3, you're moving it to the left by subtracting. Because if you subtract 2 from -1, you get -3. The more you subtract, the more negative it gets. So subtracting translates the figure to the left. And that's subtracting from the x-coordinate. So you see how this is x plus or minus a? If you do x plus a, you're moving it to the right a units. If you do x minus a, you're moving it to the left a units. Whatever a could be any number. Okay? Well, so that's the x-axis. Well, what about the y-axis? Kind of the same but slightly different. Changes to the y-coordinate will slide a figure vertically. That's up and down, just like our y-axis goes up and down. No tricks here. Okay? So same thing. If you notice this, goes 1, 2, 3. Goes up when you go up. It's obvious. Numbers go up as you go up. So adding translates the figure up. Subtracting, makes sense, right? This is -3. I'm running out of space on this, but you get the idea. Subtracting translates the figure down. Okay, so y plus b is moving the figure up b units. Y minus b is moving the figure down b units, and b could be any number. Okay? So you can use this little compass to help you, like when you have the x and y axis like this, because you know it's getting negative down here. Move down, then it's -y. Move up is positive y. Move right is positive x. And move left is -x. You can subtract, get rid of all these little lines. Then you have this little compass, that can help you kind of visualize when you're trying to do the rules, right? Okay, plus y goes up, minus y is down, x plus is right, x minus is left. And that'll be important here in a bit. Okay, so now let's look at the practice. Given words, what's the rule? Okay, so what would the algebraic rule be for a translation? 5 units to the left and 2 units up. Here's the numbers, 5 and 2. Okay, so there's a couple steps here. you want to obviously read the problem to identify keywords and figure out what happened to the shape, and then use the keywords to write the rule. Okay, so it says 5 units to the left. When we're going left, right? When we're going left, that is a change to the x-coordinate according to this right here. Subtracting translates the figure to the left, right? So, moving to the left affects x, and when you move to the left, x is getting negative. You're subtracting from x. Okay? So that means that you would have to do x minus 5 for this part. Because when you are moving to the left, you are subtracting from x. Okay, when you're doing 2 units up, okay, the word up, well, we already know this has to be y because the other one was already x. So this is y going up. If y is going up, that means you are adding because that's positive motion. So then our algebraic rule starts with this. This part is always the same in the rule. Always starts with this. Then we have the new part, x minus 5, y plus 2. So this part moves the figure 5 units to the left. This part moves the figure 2 units up. So you put those two together and you get the full movement of the figure moving 5 to the left and 2 up. Okay? So let's look at the next one. Now what would the algebraic rule be for a translation 4 units to the left and 7 units down? So same thing. We have our keywords here, left and down. Left affects x, and left is a negative motion, so you're subtracting. 7 affects y. Oops. 7 affects y. We're going down, so that's also negative motion. So our rule is simply xy, arrow, x minus 4, y minus 7. Okay, so for number 3, I want you to try that one on your own. Okay, but here's the keywords. Look at those keywords, figure out, okay, is that a positive motion or a negative motion? How is that going to influence your rule? Alright. Okay, next type of question. Now we've got shapes. So given shapes, what's the rule? And the IXL practice is going to be like this, okay? So listen up, because your IXL practice will have problems just like these ones. Okay, so let's look at number 4. Triangle BAT was translated to create triangle B prime A prime T prime. Describe what happened in words and write the algebraic rule that describes this transformation. Okay, so we've got a couple of steps for this. First step is pick a point. Pick a point. Right, well, we'll do it in pink so you can see it. I'm going to pick T. Here's T. Okay. Now this T is important because this is T prime right here. This is T prime. So that means that this is my pre-image and this is my image. That's very important. Here, I'll write the word image over there. It's really important. Okay. So after you pick a point, you want to pick the prime point of the one you just picked. Has to be the same letter. Okay, so since I picked T, my prime point is T prime. I cannot pick T and B prime. Bad things will happen. You'll get a wrong answer, so don't do it. Okay, after that, we get to step 3, so we're going to count. Count to see which way and how far the pre-image slid. Ignore this, yours doesn't have this little extra. Count to see which way and how far the pre-image slid. Okay, well, so now we're going to count. This is very similar to when we calculate distance between 2 points. You want to connect them. On IXL, you can't really connect them, so you'll have to just count and zoom in. Right, zoom in and count. We zoom in because we want to know exactly how far down and how far to the right it went. So we'll count from T down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it went down 11. Then it went to the right. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So after we count that, we can write down what happened. The figure slid 11 units down and 8 units right. We'll then use this information to write the algebraic rule. Okay? Units down is y minus, right is x plus. So xy goes to x plus 8, y minus 11. X always comes first. Okay, and then that's the answer right there. That's our rule. Okay, let's look at another one. Number 5. Triangle CAB was translated to create triangle C prime A prime B prime. Describe what happened in words. Write the algebraic rule that describes this transformation. Okay, so we pick a point. I'll pick C this time. C and C prime. Okay, pick a point, pick our prime point, C and C prime. Now we count. This time I'm going to count to the side first because X comes first, so that might be easier if you count sideways first and then count the up and down. Doesn't matter, you just have to make sure you get it straight, because if you count up and down first, that's fine, but then don't do X minus that, you know what I mean? Side to side is X, up and down is Y. I'll zoom in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we went to the left, 12. We know, how do we know it went to the left? Because this is our pre-image right here without the prime points. And this is our image. So that's how we know it went left and not right. Okay, so left 12. Then it went down. How far down? 1, 2, 3, 4, 5, 6, 7, 8 down. Okay, so the shape slid 12 units left, 12 units left, and 8 units down. We can then use that to write our rule. XY becomes, left is X minus, right? So X minus 12, down is Y minus, so that's Y minus 8. Okay? So with that, that is how you solve those problems. You pick a point, pick the prime point, and count. It's just like doing distance, except you don't take the new two numbers and do Pythagorean theorem after. You just use the numbers to make your rule. Okay? So I want you to try number 6 on your own. Same steps, different problem. Okay? Finally, we get to this last page where we are doing problems with only vertices. Okay? So number 7 says quadrilateral. A quadrilateral is a shape that has 4 sides. Okay, quadrilateral ABCD has these vertices. After the translation, where they give us this rule here, this translation, what are the new vertices? So we're basically going to take this rule and apply it to each of these points. So first I'm going to rewrite these points. All I'm doing is rewriting these from the problem. Just taking these right here, writing them down, because I feel like it's easier to do it when you can see everything side by side. Okay, so for each of these we are going to do, oh, you know what, let me color code. That'll make it easier to see, I think. Alright, my bad. Make all of the X's red. And we'll make all of the Y's blue. Okay, so what we are going to do now is apply the rule. Now the rule says X plus 3. So we're going to take each of the X's and add 3 to it, and then it is Y minus 1. We will take each Y and subtract 1. Okay, so let's do this piece by piece. So for A, you have negative 1 as the x, so you take -1 and you add 3 to it. Our y is 2, so we take 2 and subtract 1. Okay, when we do that, we do this motion. Here's the work. This is the original points. This is the work that we're doing here in the next column here. This is the work. So then we get a prime, okay, by doing this math. -1 plus 3 is 2. 2 minus 1 is 1. So a prime, and don't forget this prime mark, a prime is 2, 1. So after we transformed this, we moved it to the right 3 and down 1, these are the new coordinates, or at least for a. Now we got to do it again for the other points. So for b prime, we still have -1 for the x, so we add 3 to that. Then now we have 5 for the y. We'll subtract 1. So when we do this, b prime, -1 plus 3 is still 2, same as with a. 5 minus 1, though, is 4. So those are our coordinates for b prime. Okay, let's move on to c. C has 4 as an x, so we'll add 3 to that, 4 plus 3, because it says x plus 3 in the rule. And then our y is 6. Rule says -1, so we do 6 minus 1. Okay, so c prime, 4 plus 3 is 7, 6 minus 1 is 5. All we're doing is adding and subtracting, guys. It's not rocket science, okay? Last one. For d, our x is still 4, so this part will be the same, 4 plus 3 here. Except this time our y is 2, so we'll do 2 minus 1. But we did do 2 minus 1 earlier, so it's a lot of reuse. So d prime, 4 plus 3 is 7, 2 minus 1 is 1, and here we have it. Our answer, our new vertices. Okay. Now I want you to try number 8 on your own. Same thing. Set up your points and then add and subtract. So here the rule is x plus 12, y minus 5. So each x you will add 12, each y you will subtract 5, and then you'll end up with a new set of points. Okay. Last but not least, we get to the last set of questions. Now we have 2 sets of vertices and we need to figure out what the rule is. Okay, so let's look at number 9. It says, quadrilateral QRST has these vertices, and it's translated to create quadrilateral Q prime, R prime, S prime, T prime with these vertices. Which algebraic rule describes this transformation? Or I said what, not which. Which would imply that you have something to choose from, and you don't. Okay, don't panic. It looks like a lot of numbers. Don't panic. This is just like when we did these problems earlier with the pictures. We pick one point. We don't need all of them. We pick one. I'm going to pick letter Q because I like Q's, I guess. So here's Q and Q prime. So I'm going to line them up. Q is -2, -10. Q prime is 6, -12. I'm going to talk about 2 different ways to do this problem, okay? This is way number 1. This is way number 2. Way number 1 is if you happen to be very good at spotting patterns. I'll do this in a different color. Okay? Well, we know that Q comes first because this is the pre-image, and then it becomes the image. So we want to think about this like, what did we do to the pre-image to get the image, right? So here's our x coordinates. Here's our y coordinates. Same thing here, x, y, x, y. Okay. Actually, we want to think about this as x1, y1, x2, y2. That might help you here in a second. Okay, so if you're good at spotting patterns, you might notice y1 is -10, y2 is -12. It's becoming more negative. So that means that you have to subtract from -10 to get -12. In this case, we actually subtract 2. Because -10 minus 2 gets you -12. So that shows you that part of the rule, the y half of the rule, is going to be y minus 2. Same thing over here with x. It starts out at -2 and it becomes 6. Well, it started out negative, became positive, so you know you're adding something. Okay, in this case it is 8. So -2 plus 8 gives you positive 6. So based on that, you could see that the rule is xy becomes x plus 8, y minus 2. Okay, so if you're good at spotting patterns, then when you line the coordinates up like that, you can see exactly what happened, and you can come up with a rule like that without really doing any math. Now, if you're not good at spotting patterns like that, that's okay. That's where method number 2 comes into play here. Okay, with this, we basically just subtract to get the difference. Okay, so to get the rule, we're just going to subtract, kind of like when we did slope, x2 minus x1 to get the x rule, and then y2 minus y1 for the y rule. Okay, the important thing is that you always do the image minus the pre-image. Or you can think of it as the new minus the original, aka the no rule, NO, new minus original. So the new one always goes first when you're subtracting. y2 minus y1, think of it that way, kind of like with slope. Okay, so in this one, x2 is 6, x1 is negative 2, 6 minus negative 2 is the same as 6 plus 2, right? It's 8. And it's a positive 8, so that's how we know, oh, it's x plus 8. It's really a little positive 8 here. Okay, y2 minus y1, y2 is negative 12, y1 is negative 10. This is the same thing as negative 12 plus 10, which gets us negative 2. So that's how we end up with these two numbers. And then you get the same rule. X plus 8, y minus 2. Okay, so depending on which of these methods works better for you, you can go with whatever helps in that sense. Okay, so when you're doing the IXL, you can actually use this method too. If it's hard for you to count digitally, just pick a point, get the coordinates of that point, and then subtract. Subtract the x's, subtract the y's, and you'll get your numbers. So this might be easier than counting, especially if the numbers are really big. It's a lot easier to subtract than to count like 15, you know what I mean? And that basically sums up our notes. You're going to do number 10 on your own as well with either method, whichever one that fits your personal preference, personal style, okay? And that is it for translations. I know this was a long video, so if you made it to the end, good on you. And I will see you in class.